All right. In section 2.5, what we're going to do is we're going to take a look at these absolute value equations that we've been looking at and absolute value inequalities, but we're going to specifically look at them graphically. We're not going to solve these algebraically. We're going to look at how to solve them graphically, only using a number line. Okay, only using a number line. So, Inigo, why don't you read for us? Nice and loud, please.
We thought of absolute value of the distance between a given coordinate and 0 on the number line. You can also say that the distance between the numbers a and b on the number line is absolute value a minus b absolute value, or the absolute value of b minus a. Notice that when we are representing the distance, we use a minus sign.
So make sense of this for a moment. If I want the distance between the coordinate 7 and the coordinate 3, you would subtract them, right? And that distance would simply be 4. 7 minus 3 is 4. But if I want the distance between 3 and 7, it's still going to be 4. 4 units. Now, you do 3 minus 7, you're going to get negative 4, but we're in the absolute value symbol now. So remember that the absolute value of a difference is simply a distance. Again, if you have two things being subtracted, and you're subtracting it inside of an absolute value, really what you're looking for is the distance between those two coordinates. So if I told you this, what's the value for A? Alex, give me any value for A.
20.
So if A is 20, Christian, what must B be?
5.
It must be 5, agreed? Because the distance between those two is 15. So the idea is that this represents distance between two things. If I switch these two, I get the same answer. I get 5 minus 20, which is negative 15, but its absolute value is still 15. So the distance between two coordinates is absolute value of their difference. Let's take a look at an example of what the heck I'm talking about here, because it's getting weird. So in example 1, we're going to solve this graphically, but we're going to check this algebraically. Stuff we did yesterday we'll check with. But if we're going to solve this algebraically, how would you translate this in words? How would you translate that equation into words? What could you say? Inigo?
The distance between, can we say x or?
Yep.
Okay, the distance between x minus 4 and 0 is 3.
Close. Let's use this term instead. Because there's no 0 involved here, right? We don't really have a 0 anymore. We had a 0 when we had nothing there. But the distance between x and 4 is 3. Okay? Remember, a and b was the last example. And we said the distance between a and b is what is the difference between the two. So the distance between unknown, which is x, and 4 is 3. The distance between the unknown x and the number 4 is 3. So let's start at the number 4. Let's start at the number 4 here. Well, if the distance between 4 and the answer we're looking for is 3 units, which way or where could that answer be? Would 10 work here? How far are 10 and 4 apart? 6 units, right? We don't want it to be 6 units apart. We want it to be 3 units apart. So what number or numbers would work in this instance? Will?
1 or 7.
1 or 7. How did you do that, Will? So he took 3 and added it to get 7. And he took 3 and subtracted it to get 1. And these are both going to be closed circle points right here. Remember, this is not absolute value, so we're not going to shade in this one. This is not inequalities, so we're not going to shade in between. But yes, 1 and 7 work. And if you want to check, simply plug 1 or 7 in up top. Plug in a 7, 7 minus 4 is 3. Plug in a 1, 1 minus 4 is negative 3, its absolute value is still 3. So we're going to use some terminology now. So let's go ahead and label the number 4 as our starting point. Call that your starting point. And what would our deviation be in this problem? What does deviation mean, and what would it be in this problem? If you deviate from the norm, what does that mean if you deviate from the norm? Christian? Yeah, you're different. You're somewhat different, right, from the norm. So deviation is some sort of difference. Well, this plus or minus 3 is your deviation. Well, where do those come from? They come from the original that we started with at the top. So if we go back to the top here, this is our starting point, and this is our deviation. Is it I in there somewhere? There it is. Okay, that's our deviation. So, and I use these terms simply because you're going to hear them again in physics or math, or rather in calculus later. So you have a starting point, and it deviates 3 above and 3 below. It's like plus or minus 3. It's called a tolerance in engineering. If you're an engineer and you build something, you have what's called a tolerance, an allowable error. So if you're making basketballs, they might have a diameter of 20 centimeters, plus or minus 1 centimeter. Okay, so again, starting point, deviation. Let's apply this idea to an example that has the same thing but with a next one, and try and figure out what you would do to figure this out. Go from one to the next for each one. So go ahead and try and figure out what your starting point is and figure out what your deviation is and identify them on the number line. And then we'll talk about where our solution is. Do we shade in between? Do we shade on the outside? Depending on what the problem is here. Take a look at what I wrote to start. Did anyone else write this by any chance? Why do you think I wrote it that way? Why do you think I wrote it that way? What have we been talking about the whole time, right? Absolute value of A minus B is what distance means, right? But do we have A minus B in this problem? No, we have A plus B, didn't we? So really, we need to think of these problems with the minus sign to start. Okay?
No, I was going to say because the minus sign didn't turn into the addition.
Yes, very good. Double negative becomes a positive there. But what we can do now is identify this as what again? What is this called? Starting point. And this is our deviation now. Okay, but remember, whenever we're taking a graphical approach to solve these absolute value inequalities, we have to have something minus something for this to work. If it's not a minus sign, it's not going to work correct. It's not going to work out properly, at least. You'll get an answer, but it will not be correct. So if the starting point is negative 3, I simply draw a number line. No math need, no algebra needed for this. I start at negative 3, and I deviate 5 and 5. So 5 above this would give me what? 5 above would give me everybody? 2. 5 below? Negative 8. Okay, so I know that those are my bounds. This is my starting value, my upper bound, my lower bound maybe. Now I have to wonder, what am I doing? Am I shading between or outside? Is it an and or is it an or is the question. Do I shade between negative 8 and 2? Or do I shade below 8 and above 2? Making it either and or. Sarah?
Yeah.
Why?
Because it's a less than or equal to sign.
So Sarah remembered from last class that when it's a less than sign, or less than or equal to is an and statement. What if you didn't remember? What if you didn't remember? What should you do?
You could make like the two separate equations.
You could do that, yes, that's a longer method though. You could do what Sarah says and solve algebraically to check, even though you're doing it graphically. It's kind of, sometimes defeats the purpose if you're going to do it algebraically. What else could you do though? There's another way to check.
You could use points.
Yeah. Remember, a solution satisfies the equation or the inequality. So pick a point. Pick a point out here. Give me a number out here. Negative 10. If I plug negative 10 in, I get negative 10 plus, I'm going to go back to the original, the very, very top. Negative 10 plus 3. That gives me negative 7, right? And then the absolute value of that is 7. So is 7 less than or equal to 5? It's not. So this region out here, where negative 10 would be, is not in the solution set. Then I would go ahead and test the point between negative 8 and 2. You can test the negative 3 or just test the simplest point, which is 0, right? Test 0 because it's in here somewhere. It's the easiest point to test always. Test the 0 in the top. 0 plus 3 is 3. Is 3 less than or equal to 5? Sure it is. So that middle region, if you test any point, again, this we know is closed circle for sure. We know that that's there. But if you test any point out here, it's not going to work. Any point out here will not work. Any point in this region will work. Thus, we shade in between. The graphical approach is a lot easier than the algebraic approach if it's set up this way. If it's not set up in a nice way, then you probably go with the algebraic approach. On the test, I might instruct you to do one way or the other, or I might say, choose the best method to solve this problem. One is better than the other because one takes less time. Okay, there's solution set form and interval notation. Oops, it's a bracket, not a parentheses, clearly. Okay, so we have bracket negative 2, comma 2, close bracket. So again, the idea here is to get something minus something else, identify your starting point, identify your deviation, locate them on the number line, and then test points in those regions to know where to shade. If you remember whether it's and or, that's fine also. You don't have to really test the point. 3. What can we do with example 3 now? This is the one that gets a little bit tricky. What's the problem you notice right away? Well, there's several problems actually. Excuse me. We no longer have x minus some number. We have some number minus twice that variable. So not only is it not in the correct order, but I have double the variable there, which is going to completely throw me off. So we need to do a little bit of algebra here. So if I were doing this problem on the test, I'd probably approach it with an algebraic approach only. But the graphical approach requires a little bit of algebra first. Now, recall from the beginning of class, absolute value of a minus b and absolute value of b minus a. Is there any difference? No, it's the same thing. Right? Absolute value of 5 minus 2 is the same as absolute value of 2 minus 5. Because in the end, there's opposites, but you're taking the absolute value. So I could start by doing what? What could I do? Yeah, just switch them first. Completely allowed. You can definitely do that, okay? Again, because the absolute value of a difference is equal to the absolute value of the negative difference. Because you're still taking the absolute value in the end. So I switch them first. Then what I recognize is that I have that 2 there. I don't want that 2 there. So what I'm going to do first is this. I'm going to take the 2 out and think about what's left over. If I take a 2 out of 2r minus 7, what's left over? What would I have to put in there so that when I distribute it back out, it makes sense? R minus 3.5. Because you're going to have to double, right? Remember distributive property, you got to multiply by both. So if I were to distribute this back out, it becomes 2r minus 7. So that's true so far, right? We're good? Now, we learned something in, I think it was like the first or second section of the entire year that told us the following. And I'm going to write it up in the top left. We learned that, top right, sorry. We learned that in the very beginning of the year. It was one of our quick rules that we went over with absolute value. And it was like, oh, who cares about this? Well, it matters now. Absolute value of A times B is absolute value of A times absolute value of B. So break these up. Make 2 by itself and put this by itself. And what's the absolute value of 2, simply? 2. So let's divide both sides by 2. Okay, again, divide by 2, divide by 2. And now what we notice is that we can use a starting point and we can use a deviation. We have both listed here. Okay, we have both listed here. So let's go ahead and do this now. It's a minus sign already, which makes it nice and easy for us. There's a starting point, and there's the deviation. Always start with your starting point, because it's obviously called a starting point. Remember that the minus sign doesn't take effect here. What you're looking for is r minus some quantity. This quantity is the starting point. The minus sign always has to be there. It's that quantity that we're interested in. Okay, so remember the distance between r and 3.5 is greater than 2.5. So go 2.5 units out and 2.5 units out. What do I have if I go 2.5 units out this way?
6.
And the other way?
1.
Good. Now, the distance between r, which is where our solution set will be, and 3.5 is greater than 2.5. So here's 3.5. If r is right here, is this a distance of greater than 2.5? Where are the distances greater than 2.5?
Outside.
In the outside, right here. Pick a number right here. This distance is greater than 2.5. If I pick this as my answer, this distance is greater than 2.5. This distance is not greater than 2.5. So what kind of a statement, Will, is this one going to be? An and or an or? An or statement. If you don't believe me, again, just test the points. Or, as Sarah noted earlier, just remember that when you see a greater than with absolute value inequalities, a greater than means an or statement out here. Okay, so again, starting point is 3.5, deviate 2.5, above and below. And you've got your, God bless you, you've got your endpoints, and then shade accordingly. Okay, then shade accordingly. What would the solution set look like for this problem? What would the solution set, in set notation, what would it look like? Nobody? Excuse me, nobody for this one? You know, yawns are contagious, right? I saw like 3 people yawn as I yawn. That was hysterical. It's terrible, though. It's so true. What would the solution set be for this? Either one. Give me one or the other. You pick. Yeah.
Negative infinity, or it's bracket.
Parentheses always. Infinity.
Parentheses, negative infinity, comma, 1, parentheses, and then it's parentheses 6, comma, infinity, parentheses.
There it is. An interval notation, that is our answer. How about set notation? Set notation? Remember, it's an or statement, so you're going to use the word or in your answer. It's going to be, ready? R less than 1 or R greater than 6. Can I steal 1 minute of your time for the last one? Is that all right? We'll be real quick with it, I promise. Not given any numbers, but it's in the form we want it in, isn't it? So what's our starting point? C. What's our deviation? So on a number line, just put C in the middle. And what is this point going to be called on the right? C plus B. Very good. And on the left? Okay, and I know that it's open circle, open circle. It's a less than symbol, which is an and statement. So I'm going to shade in between. And my solution set for this will be C minus B less than X less than C plus B. Okay, so it starts at C minus B, goes through X, all the way to C plus B. All right, cool? Nice, good job, guys. Tomorrow or no, it's tomorrow day off.